Okay, so we will continue with the I/O subsystems. So today we will be discussing about 7-segment LED display. So all of you would have seen this diagram, this particular 7-segment display in your electronic subjects. So here, this is actually a 7-segment display widely used for displaying some of the alphanumeric characters. Now, it contains 8 light emitting diode segments arranged in a special form. Out of the 8 LED segments, 7 are used for displaying alphanumeric characters. So now let us see what are the 8 light emitting diodes. So A, B, C, D, E, F, G. So 1, 2, 3, 4, 5, 6, 7. And this is the 8th one. So among this, 7 are used for displaying the alphanumeric characters. And this 8th one is just to help for sending the 8-bit data. So this segment we will not be using for displaying any character, but it is part of the circuit. As we know that we have 8-bit controllers and we'll be transferring data in terms of 8-bit. So for that, we will be having this DP, one substitute. Now, the LED segments are named A to G. So these, each one of them are called as segments. That's why we call it as 7 segments. And there's a decimal point. DP is a decimal point. LED segment is named as DP. So each one is a segment. So what does this segment contains? It contains a diode. So A is internally one diode, B has internally one diode, C has got a diode likewise. It has got 7 diodes. Now let's go to the next slide. The LED segments A to G and DP should be lit accordingly to display numbers and characters. So these numbers should be lit accordingly. Suppose I want to display C. So what are the segments I'm going to enable? A, F, E, D. I want to display E, means A, F, G, E, D for displaying E. But you can observe one thing here. I can also display numbers like 0. What 0 means? A, F, E, D, C, B. 1 means I can either enable BC or E, EF. 2 means I can go like this, A, B, G, E, D. But one thing you can observe here, we cannot display all the characters. Something like W, something like X. It is not possible to display such kind of characters here. So in that case, we may have to make use of LCD. So whatever you're seeing now in metros and whatever you're seeing in the Volvo buses, the display segments, they make use of LCD. Means everything is pixel. To display any character, I will make use of pixels. So it will be in the form of matrix form, and we can display any character using that. So that is a drawback of LED. So wherever we can use LED, we will make use of LED. Wherever it is not that, where it is not adequate, then we'll go for LCD for displaying some characters like that. Now let's continue. The 7-segment LED displays are available in 2 different configurations. Yes, they are available in 2 different configurations. What are they? One is common anode and the other one is common cathode. So all of you know I'm making use of diode. So it has got anode and cathode. So in the common anode configuration, the anodes of the 8 segments are connected commonly. Whereas in the common cathode configuration, all the 8 LED segments share a common cathode lines. Means here every segment has got a diode. So all the anodes of all the diodes are connected to one common lines. All the cathodes of all the diodes are connected to another common line. That is what it tells. Now, based on the configuration of 7-segment LED unit, the LED segment anode or cathode is connected to the port of the controller. In the order, A segment to the LSB and DP segment to the MSB port pin. So now all of you know what meaning of port. We have seen in 8255. You have 3 ports, port A, port B, port C. And each port are of 8 bits. So imagine imagine an application wherein the processor wants to send some data to the LED. So the processor will send it to 8255 and it will choose any of the ports. Assume port A it is sending, it is choosing. So port A 8 pins, it will choose to send the 8-bit data. Those 8 bits of the port A, those 8 bits are connected to this 7-segment display. I'm telling it in a very simple way. You have so many other settings to do, but right now just assume this applications. So microprocessor is choosing 8255, port A, it has got 8 bits. So the 8-bit of data is sent to that port A. Through that port A, those port A, if it is connected to this 7-segment LED, then those 8 bits, each bit of the port is connected to, assume each bit of the port is connected to one segment. Now, when I'm talking about 8-bit, then which is LSB, which is MSB? So as per the statement here, the A segment to the LSB and DP segment to the MSB bit. So you have to do some calculations for that. Anyway, it is not there for your syllabus. Still, I'm telling. So out of that 8 bits, the 0th bit, whatever you're sending in the 0th bit will come to A, and in the same way, it just proceed for the rest. The last one, that is the 7th bit, will, whatever value you're passing, 1 or 0, will be substituted to DP. This is how it is working. Let's continue. Now, the current flow through each of the LED segments should be limited to the maximum value supported by the LED display unit. Means whatever the current flow it is supporting, it cannot exceed the maximum value that it can hold. Now, what is the typical value for the current? It is maximum 20 milliamperes. Maximum it can carry up to 20 milliamperes. Now, the current through each segment can be limited by connecting current limiting resistors to the anode or cathode. If it is excess, you can connect the resistors to anode or cathode. So now you are seeing here, the left hand side is common anode. So all that A to DP, whatever is there, okay, you are seeing the anode part of all the segments, they are connected to common anode line. So it is active high. Means if I want to activate segment A, then I have to pass 1 to it. If I want to activate segment F, I have to pass 1 to that particular line. That bit should be 1, then only this line will be 1. The remaining will be zeros. Only then that particular segment gets activated. Now coming to common cathode. You're seeing all the 8 diodes, all the cathodes of all the 8 diodes are connected to the cathode line. Means it is working with active low. If I want to activate, means I want to display this particular segment A, then I have to pass 0 for it. Only segment A I want to display, I want to highlight. Then I'll pass 0 for this, and the rest all I will pass it 1 because it is common cathode. So this is briefly about the 7-segment display. So I think in the lab you may have one experiment on this. We have to see, but it is with respect to ARM controllers. You'll not make use of 8255. You'll make use of other interface board. But anyway, the concept of ports remains the same. Okay, we will see that in the labs. Now let's go to the next I/O devices, that is optocoupler. What is optocoupler? Optocoupler is a solid state device to isolate 2 parts of a circuit. Optocoupler combines an LED and a phototransistor in a single package. So what do you understand here? Optocoupler is a solid state, and they are mainly used to isolate 2 parts of the circuits. You have the entire board in that you have 2 circuits. To separate that, you make use of optocoupler. And the optocoupler combines an LED and a phototransistor. So that particular thing is also one IC, which separates 2 parts of the circuits. In electronic circuits, optocoupler is used for not only for circuit isolation, it is also used for suppressing interference in data communication. To suppress the noise, we are using optocouplers, circuit isolation, high voltage separation. If there are too much of voltage, you can separate that. Simultaneous separation and intensification of signals. You can simultaneously separate it, and you can separate the noise and you can intensify the signal. Now, optocouplers can be used in either input circuits or in the output circuits. Means it can be used either for input or output. We will see that in the next slide. So now whatever you're seeing here, it is a simple optocoupler. So you're seeing here there are two IO interface. So you want to separate these two IO interface. So this two IO interface is separated by optocoupler. That is nothing but LED with a phototransistor. So now we will take one more example situation wherein I have a microcontroller and I want to connect one input interface and the output interface. So here there is an input interface and here there is an output interface and I want to separate that. How will I do? Definitely to connect to input interface, I need a one port, and to connect to another output interface, I'm using another port. So in this case, I'm using two different ports, one for input and the other one for output. Need not be, but here we are using it. Now, this particular microcontroller has to be separated from the input interface. How is that made possible? We'll make use of one optocoupler. So you can see here, optocoupler IC-MCT2M. This is one particular optocoupler. It is going to separate the input interface from the microcontroller. At the same time, I'm also separating this microcontroller from the output interface through another optocoupler. You're seeing here, this is another optocoupler. You're separating the microcontroller with the output interface. So for this, in this way, the optocouplers are mainly used to separate the two circuits. So it has got its various applications and widely used.